Okay. Yeah, shall we start?
Yeah, let's start.
Okay. So, hello everyone. Welcome to our weekly stream. Today we're gonna talk about the latest release, and Simo, who developed the new shadow system, will show us how awesome those shadows are. And we will see other features from that release, which was a huge one. And you guys can ask questions about the release or about anything really. You can join us if you want. You can join us with your webcam and speak to us with your voice. If you are on, you can join us on Discord. Below this stream, there is this Discord link, and you can join there. And then you can just join the Cablescast channel, and you can just talk to us if you want. Don't be shy. We really love to see someone new, someone we don't know yet. And that would be great. Yeah. So I want to show, first of all, I want to show something from the community in the beginning of every stream. So I don't know, something like the patch of the week or something. Not really planned, but we saw this awesome patch and we were so, we love this thing. Let's enjoy it for a moment. It follows your mouse, and the guy is really alive, I think. It also has sound. I hope the sound works. I don't think so. Because of this.
For over 10 years.
The ecosystem is bulletproof and has a massive amount of options.
The base is interactivity and can be as simple as the position of your mouse or a scroll bar.
But just as easy a link to a database.
The files are lightweight, play on your graphics card for performance, and will integrate into any website.
If you want to hear more and how it can apply to your projects, then give me a call.
Or drop me a line.
Yeah, it's amazing. It's so good. Yeah, and Suzanne, however you say that, published a lot of really cool patches. You should check them out. And they are also really well organized and interesting. And yeah, as always, you can look into public patches. And yeah, if I was like, how did he or she, I don't know, do the mouse movement?
Raw Ego has something new.
Because it looks so good.
In your browser that can be used for
And it's really just the audio analyzer, and just like the average volume is scaling the mouse up and down, and works so good.
Raw
really
Ego has
surprised by this. Love this patch.
Yeah, I absolutely love it. I didn't think it was so easy with the mouse, but yeah, that works really well.
Let's feature it.
Let's feature it.
No, really great thing. I love it. Another thing that we wanted to show from today, actually, in our Discord, the user Akagawa, probably wrong how I say it, but yeah, he or she posted this link to a website that was done with cables. So let's have a look at it. And the website is using a cables GL patch as the background, and it's just changing over time. And the real content is overlaid over this background, which works also really good. I think we had like an earlier version of this background on Instagram. So actually, it was published then if we featured it on Instagram. So let's have a look. I don't know the username, but maybe I can find it quickly. Huh?
Isn't it the same as his last name, actually?
There. Yeah, he published a lot of stuff. Yeah, so this patch has already 18 likes. It's really big. Let's also feature this. Am I missing sound on the website? But yeah, so this was also published, so you can have a look at it, how we did it. So am I missing something? Maybe I can turn on sound. Probably, right? We don't know. Yeah, here. Nice.
Yeah, that's really cool.
Okay, it's only after this. Oh, what did I press? Yeah, you can explore this website on your own. You see there are some secrets, and you can find new content. Yeah, but really cool website. We need to put it on our Made with Cables page. Cool. Yeah. So if you made something with cables or used cables for anything, just tell us. We love to see this stuff. Just put it in general or publish it, or just tell us we want to feature this and we want to show this on the website. And yeah, just tell us really what you are doing with cables.
Yeah, publishing it is like a good way to get our attention, right? So we get this bot channel where we get like every published patch, and I really like going through this like every day or something, just scrolling back and see what the people do on cables.
Yeah, but also if you're using it in a real life project that's external from cables, please just tell us. And you don't need to publish. If it's a bigger one or whatever, you don't need to publish, but just tell us. This makes us so proud to see those kind of projects. Makes us really happy and motivates us. Yeah, Stefan, you wanted to say something about Novoke, maybe?
Right now, yeah, because we're still in the process of starting a new cables jam. Maybe that's a good opportunity to say something about Novoke, which is the replacement for Evoke. That won't happen this year because of situations arising, basically. We're doing this online. It's going to be an online demo party with a few competitions, music competitions, graphic competitions, executable, real-time competitions. It's going to be on the 15th of August, and from 1500 to I don't know, something like 3 in the night, with talks and DJ sets, competitions, moderation, and yeah, everything in between. This is really a huge hobby project of Tom and me, with a lot of other people also doing lots of work. We'd really love to see you there, and maybe if you still get the time, do something in cables and enter one of the competitions. You might even win something.
Yeah. So yeah, exactly. So usually this is called. It's always in August, and it's called Evoke, which is like a real-time animation festival, basically. So there are like a few hundred people that are developing and drinking beer and listening to DJs. And this is in Cologne usually. So because of the whole COVID-19 situation, we cannot do this in real life, so we are doing this online this time, and yeah, it will be streamed on Twitch. It's the whole, basically most of the 15th of August. And if you saw last week's episode, something like Daya and KB did, stuff like this will be shown there. Is not everything is done in cables, but some things sometimes. And also like this website we did with cables, and also the whole system. Maybe we will also do a stream about that, I thought. The whole system that shows information and shows like the competitions and stuff like this is done in cables by us. And yeah, so if you want to see this, try this out. There will be a timetable here when there will be the interesting competitions in the evening. And yeah, check it out. Yeah. So then our next point is the new release. So probably you heard already that we had this new release last week. Actually, today we already made an update. It's not here yet, but we already fixed quite some bugs that were stuff that was going wrong. But all in all, it's going fine, I think. So we will publish the information that what we changed tomorrow, I guess. And yeah, so we will go through this list and check some things out. But probably like the biggest thing is the shadow system from Simo. He wrote it. Hi, Simo.
Hey everyone. Nice to
And,
finally be on the stream.
Yeah, you were never on the stream, right?
I was in the chat making cheeky comments, but never on cam.
Yeah, so Simo is also working at Undev. And so Simo, tell us what like was one reason why you made the shadow system was not only because you like shadows so much, right?
Yeah. No, not only. So maybe
You
I
live
can
in the
introduce
shadows.
myself.
No, so.
Yeah, my apartment is kind of shadowy all the time, so I kind of do live in the shadows. But yeah, apart from that, maybe I can introduce myself and how I got to Undev and why this whole shadow thing actually started. So I study computer science for media, and I started working at Undev about 1.5 years ago. And I was in October last year. I finally got to the point after a long study where I'm finally able to write my thesis, my bachelor thesis. And I thought since I work at Undev and do so much with computer graphics, it would be cool to write about a topic that could actually benefit Undev as well, and not just only me for academic purposes and then get hidden in a drawer forever. So Tom and me, we discussed about what we could actually add to cables. We had a few options of bigger systems. We talked about, I think, PBR and shadows were the two main ones. And then I went to my professor, and he said, yeah, PBR is too easy, so do shadows. And which was cool, by the way, since PBR is much more difficult, in my opinion, but whatever. So yeah, that's why I started writing the shadows, basically. And I've been writing them since, I think, October. October was the time when I started. I got the first version working, and then we realized, okay, there are some problems with the engine, so we had quite a bit of stuff to prepare before we could actually release the shadows in a stable version. So yeah, that's how I wound up writing the shadows. One for my thesis and second for Undev, or the other way around actually. First for Undev and then for my thesis.
Yeah. And will this thesis be public after that?
I hope so.
Okay.
I don't know actually. I never even asked, but I'm in the process of writing bigger documentation, which features parts of the thesis. So for anyone technically interested, they can of course always contact me on Discord and ask for the thesis. I will gladly send it once it's published. So shouldn't be a problem.
Cool.
But I will get back to you with that. Yeah.
So if you have been working for this for quite some time, a few months basically, what were the greatest challenges any one thing
So
that was, yeah.
yeah, there actually were quite a few challenges. In the beginning, it was completely overwhelming on how to like add a multi-pass rendering system, which shadow mapping basically is, into cables so that everything runs smoothly. I mean, you guys know that we have some picking ops which use that kind of mechanism, or also some other ops like particle systems. But with this one, it was kind of a bit more difficult because you had to, I don't know, you have 3 ops all rendering 2 passes. You have to make sure that they work in combination. You have to make sure that they work alone. So the algorithm itself was not that difficult. I think that took like 1 or 2 months to get right, but then integrating it into the ecosystem and making it work flawlessly was, I think, the biggest challenge
But as
so
we
far.
will then see, I think it was absolutely worth the wait. And what you get from it is like a really modular system where you can like just pick and plug in shadows and lights everywhere, right?
Yeah, totally. I mean, it still comes with a few caveats here and there, and I guess it's not 100% perfect, but which software is, right? So I think the state we are at now is a pretty good one, so you can definitely use it for your demos and for your websites and everything. So yeah.
Yeah, as always, it's a work in progress. But I also think it's really usable, and yeah, we just have to use it now for real, and see
Yeah.
what comes up. Yeah.
So before I dive deep into it, I think also when you showed it the last time, since we didn't have proper documentation yet, the different algorithms work differently, right? So you gotta know which one you gotta know how to use which one. So I will show it to you a bit later, but it takes a little bit of getting used to the different settings and what they can do before you can actually get good results. But 80% of the times works right out of the box. So I think we also got some good default values in there, and yeah, I'm excited.
Yeah,
to
I
show
think
it to
we
you
will
guys.
also make more tutorials about this, also with Andro, and you are writing a big documentation, right?
Yeah.
How to use it, and what's the performance issues where you can run into, and or like what artifacts are there and how to solve them and stuff like this. Yeah, so we are still working on this, but we just wanted to get it out and get people to use it, and then see how it goes.
Yeah, I'm very excited. I can't wait until people make some patches. I saw that Frau Mimimi already published something, which was quite nice. It was the first
really?
published patch with the shadows. Yeah, something with the new Fong material, I think. Came right after the update. I'm not sure, but so far people have been maybe hesitant to use it. Maybe everyone's on vacation. I don't know, but I'm very excited.
It's only
to see
5 days.
patches with it. Yeah.
It will happen eventually.
Yeah,
So
I can't wait.
cool.
Let's show something, right?
Yep. What do you think? Should we start with a very simple example and I explain a little bit how everything works, and we start to move forward with a bit more advanced stuff then?
Sounds great. And for all the people, like, if you have any questions, just type them in the chat, and we try to relay them to Simo while he's working. So, yeah.
All right. So, should I just open my patches?
Yeah. Just do what you want.
Okay.
You can also log out if you want. If that's easier.
Yeah, sure. Can I see my user here somehow? My patches, or the quick thing?
Yeah. Let's do it. Do you know your password?
I know my password. Yes.
Okay.
Yeah. Let's just do it like this. Okay. All right. So I prepared a few examples, and the first one I want to show you is the most basic one. It is kind of like the example that is published with the op. Can everyone see it? If I can open it. Oh, there we go.
Let me try something, okay? 1 second.
Yeah.
Yeah, I have no idea. Let's try the development server.
Look it on my computer really quickly.
No.
So maybe just start from scratch then.
Can you clear your cache? So I can also
Yeah,
start from scratch. Okay, for me it works. It works on my machine, right? But yeah, I mean, I can patch it up really quickly. It's no problem. Done that quite a few times. So.
Okay, wait a second. The other one works. So the complicated one works. So I don't think it's a big thing. Okay. You do your magic.
Yeah. All right. Yeah. Okay, I will just create an empty project. Oh. So we're doing it on dev, yeah? Sure. All right. So
now try
always.
It on. I don't know.
I'll just start really quickly. It's very easy to set up. So for everyone that has not worked with shadows, first we need to patch something that receives shadows, and we need to patch something that casts shadows. Maybe a bit of terminology first, so you know what I'm talking about. Something that receives shadows, it's called a receiver, and something that casts shadows, it's called an occluder. And I will try to refer to these terms while we're working on it. So first thing I'm going to do is add a floor, which I will use a cube for. I will go into more detail on why I'm using a cube a bit later, but first thing to write down, always use a geometry.
Sorry, Timo. Can you wait a second? Because I don't know why I'm logged in now again.
Because you're on dev, most likely.
Let's do it on live, and then it's fine.
Okay, sure.
Sorry. Yeah.
No worries. Okay, guys. So test for you. What's a receiver? What's an occluder? Just kidding. So the basic scene will be: we have one geometry. It's going to cast a shadow onto a floor. The floor is going to be a cube, and the geometry I pick now is going to be a torus. So let me set up the floor really quickly. Before I do that, let me add a camera control, orbit controls, my favorite camera control. Yeah, so let's first create a floor. Now, what do we need? So to be able to cast shadows, we always need a material, right? So I will take the Lambert material because it's the more simple one. Before getting into detail with all what the material can do, I will just take the simple one. Let's make some nice colors, and now let's add the geometry we want to cast a shadow and occluder. So I will take the torus. I like the torus because it has a hole in the middle, and it's good for seeing shadows. So here's our scene, as you can see. It's just a torus with the floor. So what do we need to cast a shadow? We need a light source, right? So I will show you everything with a directional light, and after I showed you the different algorithms, I'm going to get a little more into the different lights that we have and how they apply to shadow mapping. Hey.
What happened?
Sorry, guys. It's very loud here on Twitch, on Discord.
I don't know how this happened. Someone.
Yeah, Keep It Visual is in here. Can you maybe turn off the sound on your Twitch for us? Keep It Visual.
There's Keep It Visual. Hi. Finally.
Oh. Bye, Keep It Visual. Okay, so let's continue then, shall we? Yeah. All right. So I will also add a material to the torus. I'll take the Phong this time just to make it look a little more shiny. So if I look at our directional light, you can now see the way it's casting, or the direction it's casting into. So keep that in mind. Now, with this update, we got a version 2 of our shadow op. And the shadow op is responsible for basically allowing you to decide whether an object should receive a shadow, whether it should cast a shadow, which algorithm it should use, and like change some parameters within the algorithm. So I will add a shadow op to the floor now. So we also added a few cool warning messages. So now you see, warning, there are lights in the patch, but none that cast shadows. Please activate the cast shadow property of one of your lights in the patch to make shadows visible, right? So we try to give you as much clues with the UX as possible so you don't feel stranded in a sea of ops. So the shadow op told us, hey, we need to activate cast shadow. So you see it here, cast shadows. If I turn that on, boom, there we go. We instantly have shadows. So it's actually pretty easy to get a default shadow example going really quickly. Now, to be in control of our torus, I will also add a shadow op after the Phong material of the torus. What you have to keep in mind, maybe for people, which I didn't know when I started out, happened to me a lot, the shader effects always go after the materials, right? So don't put the shadow before the Phong material, always put it after. So you get the results you expect. Okay, so what can we do now with this shadow op? As you can see here, we're casting a shadow. You see here, our torus is not properly on the floor, so we have this kind of white spot here. Do you see my mouse?
Yeah.
But I guess you know what I mean, right? So let's try to raise the position a little bit. Yeah, there we go. Okay, so you see out of the box, we have proper shadows. Now, what can I do with the shadow op? So basically, I can decide if I want an object to receive a shadow, or if I want an object to cast a shadow. So if I deactivate cast shadow, everything that follows the shadow op is not going to cast a shadow anymore. But we want our torus to cast a shadow, so we keep that activated. But we don't want it to receive a shadow, since with this example, we'll just use a minimum of one receiver. So now, the basic shadow thing we're seeing here, this is the default algorithm, right? It's called default. And you can move your lights around, change the direction, and maybe what's interesting, you can always see what the light's camera sees when you mark or click on your light operator. So let me change the X direction to show you what I mean. So if you see, I'm turning it. Oh, now I turned too much. Sorry, I have to write it. Right, so I can type 5. I can type -5. And you see the camera of the shadow map changes, and also the shadow on our main patch view changes. So you can play around with these properties and like check out how you want the shadows to look. Now, that's all you need to add a shadow, basically. There you are. You have a shadow. So
That's pretty cool.
If there are no questions in the stream, I would like to show you the difference in the algorithms now.
Yeah,
no
just ask
questions.
us if you have any questions. You can always ask us, and you can also try to join again if you want. I turned off the sound signal, so it should not be too annoying if you want to try it out again. But please turn off your sound. Maybe I didn't turn them off. Turn off your sound. Maybe I didn't turn them off. Okay. Yeah, I think you can continue. Sorry. Maybe we'll do this later. Maybe that would be a better idea. Sorry.
Yeah, don't worry. I'm all right. So the default shadow algorithm. The algorithm itself is from 1978, so that's a long time ago. And
this is called shadow mapping, right? Or...
I actually wrote that down in the documentation. Sorry, I don't have it open anymore. I think it's called Casting Curved Shadows on Curved Surfaces was the title of the actual paper back in 1978. So this is a very old algorithm.
Okay, but the whole technology we are doing is called shadow mapping, right? With textures, basically.
Yeah. So maybe I can explain the process just very quickly. What we're basically doing is we're taking a fictive camera, we place it at the light's position, and we render what the light sees into a buffer. And once we're back in the material, we compare the values in the buffer to the values on the screen, basically, or in our actual scene. And what we're doing is we're saving the depth values. So how far is my object away from the light, and can I still see it from my normal camera? And if these values, you compare these values, and if you don't see it from your light, but you see it from your camera, you basically get a black pixel. So it's actually a pretty simple mechanism for people who understand anything about computer graphics. And yeah, what I wanted to say, the basic algorithm is fine for actually adding shadows, but as you can see, we have these jagged artifacts, right? And I think they're more prominent when I do it like this. So if I change the map size to 256, 512, the higher the resolution, the less edges you get, the less jagged edges you get, but you still have them with this algorithm. So
but that comes with performance drawbacks, right? I cannot just basically switch these for free to whatever I want.
Yeah, sure. You have to keep in mind that the higher your texture resolution, the less performant it will be, and especially if you're interested in making it work in mobile, you should definitely try to stay at a max of 1024 if you plan for an iPhone 8 and above, iPhone 7, but if you're going below, I guess 512 and even 256 would be better. But I will get into the map size a little later because I want to show you the difference of the algorithm. So the problem with the default algorithm is that you cannot get soft shadows. So what are soft shadows? Soft shadows are shadows that basically blur out at the edges, right? So they get lighter at the edges, which is what real shadows look like. I don't know if you can show it here on my... Yeah, now you can see it on my wall. Like the shadow there, it fades out. And if you look back at the screen, you don't see that. We have really hard edges. So computer scientists from all around the world, they wanted to get soft shadows. And there were numerous algorithms written about this. Some persisted, some don't. For my thesis, I chose 3 algorithms that are able to produce soft shadows. And these are the ones that I'm going to present you right now. So if you want soft shadows, the first thing you can do is check the next algorithm. Et voila. So as you can see here, if I zoom out a little bit, you see with the PCF or percentage closure filtering algorithm, we are already starting to get pretty good looking soft shadows. The algorithm itself basically works by linearly interpolating the values of the map. I won't go into much detail with that now, but just think about this algorithm as taking the average at the borders of the shadows and trying to smooth it out a little bit. So what can we do with this algorithm? We can set the amount of samples that we want to use. So maybe I will just show you what happens if I change the sample amount. So if I use a 1 amount of sample, So you use a sample amount of 1. We're basically getting the same result as with the default algorithm. So you can always backcheck with that to compare. So if I use 2 samples, we get a bit of blur. If I use 4 samples, we get even more blur. And if I use 8 samples, starting to look pretty swifty, right? So I would recommend using 4 at most, especially if you work with texture resolutions of 1K or above, because this process can get very, very expensive. So try to keep it with 4. There are other tricks with which you can make the shadows appear softer, which I will get into a bit later. So this is second algorithm. I actually, from all my testing the shadows, I prefer this one when I'm using multiple lights, because it's the most, you can basically, you get what you expect, right? So there won't be any weird light issues, shadow biasing issues, stuff that we're going to come to a bit later. But I prefer PCF for multiple light setups. And yeah, I think that's about it that I can say. Oh, sorry. So the next one I want to show you is the Poisson algorithm. I am allowed to click here, which I'm not. Sorry. Ah, yeah, there we go. Hello again. Okay. So the Poisson algorithm. Basically, the Poisson algorithm works like PCF, but instead of linearly interpolating the values, it samples points that are distributed on a so-called Poisson disk. I will not go into the technical detail, but basically think about it of creating a noise around your shadows, or like a noise-like pattern to blur it out at the edges. So here again, we can choose different sample sizes. So 1, we have the default pack. 2, we get a little bit of blur, as you can see. 4, we get even more. And 8 starts to look good with this one. So as with the PCF here, I would also recommend using 4 samples. And the Poisson algorithm exposes another parameter, which is called sample distribution. So let me lower this to show you what it does. So if I put it on 50, see, I get weird results. It's kind of what this does. It basically, I change it to 100 now. Let me change it to 150. 150. Oh, sorry. 200. So what I want to show you is the more I increase the value, the lesser the blur, basically. So if I'm at 500, I have very, very little blur. So what this basically does is it defines the amounts of points that we sample at the edges. So the higher the sample distribution, the lesser the distance between the points that we sample. So think of it as, if I decrease this value, I can get these blurry kind of shadows. And I think a good value for this distribution is 250, 300, depending on your desired looks. So with 8 samples, 500. And if you get into the 600 or 700s, 800s even, there won't be that much of a difference. So 1,500. So you see, we have 1,500, we're almost back to the default algorithm. So try to keep this value when you're using the Poisson algorithm between 100 to get this kind of look, and 500 to 800. So 150 to 800, I think, is a good value for the sample distribution.
This 100 value gives a cool old schoolish look, I think.
Yeah. I mean, what I can
you
do
blur
here,
this a bit more? Those pixels there. Is this the shadow or the map size, or?
Exactly. That's what I wanted to show you. So right now we have a map size of 512. If I decrease it, you see we're getting these edges. The higher I increase it, the softer it gets. So There are other factors involved in getting smooth shadows. These look jaggy because of our map settings, which I will get into in a bit when comparing the different lights. But basically, use the sample distribution to kind of like stretch your shadows or like have them overlay with multiple shadows if you want that. Okay, next up, VSM. What a cryptic name, right? So VSM stands for Variance Shadow Mapping, and it's a fairly new algorithm. I think it's from 2006, so actually pretty recent. Still old in a way, but recent. So let me turn that on to show you what it does.
But isn't all the other stuff like basically 70s math or something like this? And the algorithms are really old, some of them?
Yeah, the ones we showed before, they're all from like the 70s, 80s, 90s, a little bit as well. Like there have been, how do you call it, Verbesserungen,
Improvements.
like updates, improvements to the algorithms over time. So maybe sometimes somebody finds a clever way to store values in an array or something. I don't know. Like people optimize these algorithms, but they are still being used in game engines. So the ones we have here, they are common algorithms that you will probably find in Unity and Unreal and whatever. So yeah. Now, VSM, variance shadow mapping. For anyone that is familiar with maths, variance comes from probability theory. And what this algorithm does, it basically uses probability theory to determine whether a shadow sample is at the edge or not. And this works by using linear textures, linearly filtered textures, and applying a blur to them. So what you see right now is what you see right now is VSM without any blur, right? So let me apply some blur to see what actually happens. Now, if you want to apply the blur, you have to go to the light. And at the very bottom of shadow map settings, you see this blur amount. So let me increase it, see what happens. I'll try to do it slowly so you can see it. There we go. Oh, now it turned to 1. But as you see, it starts to look pretty convincing if I turn up the blur value. Let me now put it on a very high number just to see what you can actually do with it, or 8 or something. So this is where you get into territory that you can use for abstract designs, but keeping the value on 1, sometimes even 2, depending how soft you want your shadows, is a good start. This is actually my favorite algorithm of all when it comes to looks. But it's really cool. So I can also try lowering the map size. And as you see, with the blur, I can use a 256 by 256 shadow map without having any edge artifacts, right? So it's actually pretty cool. But it does come with its own problems that I'm going to get into in a second. But basically, whenever you can, whenever your scene permits, try using variance shadow mappings for the nicest and smoothest soft shadow results. So let me increase the map size again, show you a bit what's happening, right? So with 1K, you have to increase the blur value a bit more. But yeah. Basically, variance shadow mapping, awesome for mobile if you design your scene correctly, because it's the second fastest after the default algorithm, and it also looks the best. So whenever you can, try using variance shadow mapping. But I will come to problems with the different algorithms in a second. So are there any questions?
There was a question of Hardy. He asked, is there a depth information for the shadow map available? So one could set the blur amount based on the distance then, but you kind of answered this with showing VSM. So I guess that works.
Okay, so he's kind of talking about like a fork, I think, within the shadow mapping with the blur. If you want the more technical explanation, what we're basically doing is we're storing the depth values not in a depth texture, but in a color texture. So we can interpolate between them when we're using linear filtering. So we're actually not using depth textures in a way which you would actually use in a normal shadow mapping algorithm. So
the old way, right? But and are you blurring it depending on the distance from camera to texel, basically, or is this the same blur
No.
everywhere? Okay.
No, it's like our fast blur up in post processing. It's the same algorithm basically.
Okay.
What we're doing is we're blurring the 2D picture, and since we're blurring it, we're getting an interpolated value, and especially at the edges, we're getting this soft look. And within the shadow mapping algorithm, you basically re-extract that and compare it to the actual depth, and then you can use it to blur the shadows. But it's not a three-dimensional blur. We're blurring the 2D texture and actually blurring the values. So I think a depth-dependent blur would be more of a fog, in my opinion. I don't know if that has been used in shadow mapping, actually. But as of now, you cannot blur by distance in the shadow mapping algorithm. That was your question.
I just wanted to know like how this works. Right? I thought it's more complicated. Sounds, I mean, not simple, but it's really like the results.
Yeah, so it's really the best looking, the most performant compared like for soft shadows, but it comes with its problems. Problems I'm going to get into a little later.
Intersecting
but if
stuff,
there are
I guess, right? Yeah.
Yes, exactly. But if there are not any more questions, then I would like to show you the camera settings of the different lights and how the different lights work. Okay, since we started with the directional light, I would love to show you the shadow map settings here. So take a look at this map. Can everyone see it? I'll increase it a little bit. Let's take the default algorithm again so we don't get too complicated. Oh, a note on the blur. You can also try using the blur with the normal algorithms. As you see, you can also get kind of soft shadows with it, but it kind of deforms your shadow a little bit. So be cautious when using it in more complex scenes. But I would recommend using maybe a little bit in your normal algorithms. Yeah. So let me put that on 0 and put everything here on 0. Sorry. 0, 0, 0, 0, 0. Okay, now we don't see anything. Okay, so that's okay. We're going to start. So what we have here with the LR bottom top, near, far, are the camera settings of our shadow camera. So just like, I don't know how familiar you guys are with normal cameras, but basically you have a viewing frustum and you define its border. So you define where's the near point, where my camera starts seeing things, where's the end point, where does my camera stop seeing things, right? So you can set these up however you want. I think the default values are pretty good. So let's try setting this to 1.
I think it's 30.
Yeah, it used to be 30. I just want to get it so that we... there you go. So as you see, you can see it on the shadow map itself. You see that the floor is kind of not completely visible. And when you have that, what you will get are these kind of completely shadowed areas. So here's tip number 2 to keep in mind. Always make sure the stuff you want to receive shadows, the stuff you want to have receiving shadows is visible in your shadow camera. It's like rule number 1. If you don't see it, it will probably be black. All right. So LR bottom top, basically the viewport of our shadow camera. So let me just decrease it a little bit, see what happens there. If I get closer and closer, you see we're getting the same artifact again. So my recommendation is always limit this LR bottom top value so that your whole scene is captured, but nothing more. So maybe here the best would be 7 actually. Yeah, 7 is perfect. So you have the sorry. You have the whole scene visible, but nothing more, right? So the algorithm works as optimally as possible, which basically
exactly.
means
So
you have.
Yeah.
Yeah, go ahead.
So just wanted to say that, like, if there's like empty space, like you have to minimize the empty space because you're just throwing pixels away. So you always have the resolution problem with shadows because you don't want your map to be 4K or something, at least not in the browser and on mobile. And so you have to use all the pixels that you can use because otherwise they're just thrown away, basically. So yeah, you have to squash it into that texture, basically. Yeah.
Let me show you
Which
what
is the
happens
problem
when
if you have a huge scene or something. Yeah.
Let me just show you what happens if you make the shadow map too big, right? So I'll increase this to 50. And as you see, I don't know if everyone could see it, but our artifacts here, they just got huge with the size of 1K. Now, if I decrease it back to 7, with the default algorithm, voila, we're getting less jaggy edges. So always keep that in mind. Like, try to make the shadow camera as fitting as possible. This will solve a lot of problems that you might encounter. So always start with the camera, basically. Whenever you set up shadows, start with the default algorithm and start with the camera and make sure that it's really, really catching the whole scene and nothing more.
So when you're saying camera, you actually mean the parameters of the light that kind of behave like a camera, right?
Exactly. So the shadow map camera, that's what I would call it here.
Yeah.
It's called shadow map settings in the parameter region. But these LR bottom near far, they are the camera settings. So what the light sees, make sure that what the light sees is only what you want it to see. Don't lose any space. Don't make it too small. Don't make it too big. Just make it a perfect fit, basically, as perfect as you can. All right. So now, other problems that can occur. Let me just activate the shadows on the torus. Let's see, does it get some? We can't see it really properly. So let me change up the light a bit so we're getting a bit more shadow. Yeah, I actually can't reproduce it right now. Give me a second. So other types problems may arise. I'm just checking. But yeah, let's look at the different lights. Maybe we'll come across a problem actually. The other parameters here, I will show them to you with the spotlight. So as with the update, not only the direction light can cast shadows, but also the spotlight. So let me just remove this directional light here. I'm shaking. Yeah, there we go. All right. Where's the light now? Okay. Okay, so let me insert the spotlight. Now, whoa, shit, we don't have, sorry. We don't have any shadows now. Let's look at our shadow up. Oh, there's a warning. So if you don't see shadows, don't forget, when you add a new light, activate cast shadow. There we go. And now we can actually see some problems. Right? You see here on the torus, we have this weird black area. So one of the most important properties with shadows is the so-called bias. So let me set that to 0. And you see, our problem is gone. What the bias basically does is, if you're getting weird Mori-like artifacts or any kind of artifacts that like cover your whole scene in a way, like little shadow drops, basically, it's a good idea to try increasing the bias. So here,
so was this a self-shadowing problem there, what we saw, or is it something different?
Yes, it was a self-shadowing problem. that was caused by having a too high of a bias. So let me increase the bias to see what happens. See, well, now it's gone. So 0.1 is way, way too much. But if I put it on 0.4, you see we have too much bias. So we're getting these like holes in the shadow, and we're getting this. Maybe I can turn the camera.
And this is basically a threshold when to cut off, like the depth comparison, or what? Probably
exactly. Right. So since our texture is limited, we cannot like reproduce the depth values to the accuracy that we want. And sometimes, especially at like borders, you have the problem that the value resolution is just too small to capture the finer details. So some parts might be shadowed while they're not, or the other way around. Some parts might be light even though they should be shadowed. So if you experience these kind of problems, sorry, I can't.
Should I click something?
Yeah, try. Try clicking in the patch. Yeah,
no.
Okay. Yeah, let me try it. Yeah, it should work now. Yeah. Okay.
So yeah, all those values have to be dialed in differently per scene, probably, right? Or per camera setting and size.
Yes, it really, really depends on the scene. Like everything that you do with the shadows it's really dependent on the scene that you're showing. So while it might work here, if we should we just try to add another geometry to make it a bit more complex in a way? Here you see this artifact. So no, okay. Yeah, maybe one more thing for the spotlight. Sorry.
Just zoom in a little bit.
Yeah. So the camera of the spotlight, what you're seeing here now, it's kind of you don't see anything, right? So the spotlight works a little differently than the directional light. It has a different camera. It has a so-called perspective camera and not an orthographic camera. It basically means that it's dependent on an angle. And the camera of the spotlight, it needs a little different near and far value. So you see, as I increase the near value, I see more, and if I increase it too much, I don't see enough. So always play around with these values until you actually see something on your shadow map, and you'll probably get good results. So now, the main, as you see here, you only have near and far, and you don't have LR bottom top. As I explained, the shadow map camera for the spotlight works by angle. So we kind of connected it to the cone angle. So if you're changing the cone angle, you're also changing the shadow map. Whoops, that was a stupid change. That too. You need to fiddle around with the parameters a little bit. So if I increase the cone angle, you see the light gets a little... Sorry, can you click again, Pandra?
Yeah.
Thanks.
Yeah, I think you cannot press escape.
Yeah, I don't know. So let me turn up the light a bit so we see it. Yeah. So you see
Can
now
you move the light a bit so we see the hole again or something? It looks a bit wrong. Or is that the bias?
Sorry. No, it's definitely the light's position. There you go.
Okay, cool.
Right. Not falling again for this one. So let me increase the height. Yeah. So here you see it. Now I decrease the cone angle, which basically makes the stuff wider. And it works in reverse order. Why, I don't know to this day, but just keep in mind, like, decreasing the value actually increases the angle. So you see, let me turn down the intensity for this one. So you see, the further I open up the angle, the more the camera sees, and you can see it here. We have the same problem again, that we're underfitting our texture. So we get these very jaggy artifacts. So when you're working with spotlight shadows, think 130. Let me increase the intensity again. 130 is a very good starting point to actually get somewhat okay looking shadows with the default algorithm. Keep that in mind. So let me try increasing it. 140, 150. Now we need to make it a bit brighter again. Yeah. So this looks actually decent for just a default algorithm. But yeah, what you can take away from this one, the shadow map camera for the spotlight is defined by its own cone angle. So whenever your scene is underfit or overfit, try changing the angle. And changing the angle not only affects the shadow map camera, but it also affects the intensity of the light. This is just the way that spotlights work. So whenever you're increasing or decreasing the angle of the spotlight, try also working with the light intensity and the spot exponent to get the look that you want. It's really like fiddling around a bit more than with the directional light with the spotlight, but you can get pretty good looking results with it as well. So yeah, let me increase the height. Oh, there we go. That looks different. Okay. We have two more parameters I want to show you. So they are the same for the directional light and the spotlight. They both have this property that's called normal offset. And what you're doing here is sometimes, right now we don't see it, but sometimes you get these jaggy artifacts at the border of your geometry. What you can do then is like increasing the normal offset a little bit. I will try to increase it a bit higher so you see what happens. So I put it on 1, which is way too much. But what it does, it basically moves your shadow along the geometry's normal. So what you can do is like move artifacts away from where they are if used sparingly. So whenever you have some artifact problem that are like tiny little black dots at the borders of your geometry, try using the normal offset parameter. The last one I want to show you is the polygon offset, where you basically, let me show that with the directional light, because there you can see it more on the map, what happens when I increase it. I'll do it like this time.
You can also press X, by the way.
To disconnect it.
Yeah.
Nice, I didn't know. Talk about stuff. Okay, let's keep it like this. So, what happened now? Ah, yeah, so.
It's probably time to reload.
Yeah, I think so too. Yeah, so you see we're still having... Yeah, you see we're still having some problems with removing and adding the lights. This stuff I'm going to fix within next weeks. But yeah, please don't hate if you find a bug. Just write to us and I will gladly fix it. So let's take this thing again. Make it 5 or 6, 7, 6. Okay, so what happens with the polygon offset? Oops. Let me change the angle a bit so we can see it a bit better. So when you have self-shadowing, can you click again, Tom?
Yeah.
Move it again. Thanks. Okay, yeah, okay, that works. So what basically happens if I use the polygon offset? It offsets my polygons into the direction of the camera. So this, as you might see now, can be used to also combat artifacts. So if the artifacts should be moved away from where the camera is pointing, try increasing the polygon offset. Like I'm overdoing it now, but this also works in negative direction. So if you want something to get closer to the camera, you can also use the -1, but this will often result in this kind of stuff. So be careful with this one. I think values between 0 and 10 or -10 usually work the best. But yeah, only use like normal offset and polygon offset if like problems you cannot solve with the biasing still persist, right? So they should be your last resort, basically. Yep. So that's it for the controls. Maybe one more thing: the shadow, spotlight, and the directional light. They have the possibility to enable multi-sample anti-aliasing. So let me show you what that does really quickly. I'm still on the default algorithm, right? So let's increase the size, 1024. Now we still have these jagged artifacts. I can turn MSAA on, and as you see, our artifacts kind of decrease. This takes a lot of performance, so caution, point number one. If you use, I think 2 to 4 is okay, 8 I wouldn't use. It's just there for the high-end PC people here in the stream, so maybe you guys can use that. It only works with WebGL2, so if you plan on using it on iOS, don't enable the advanced mode because it 100% sure won't work on iPhones or Safari. Yeah. Okay. So that's it for the controls. Now, are there any questions regarding the controls?
No,
or
no
anything
questions.
else for that matter?
I just wanted to say that I really like how, I mean, there's like tons of different parameters that you can tweak, and we were aiming for correct and smooth shadows, but everything in between that you deem to be an error or wrong also had like cool effects that might be wanted, and just like really nice to play around with it and see where you're going, and then maybe finding something on the way. That worked really well.
Yeah, totally. I also think that like we still haven't done any post-processing, and I don't know if we are able to do it today, but like imagine using these messed up shadows with like cool blur effects or I don't know, edge detection or whatever. I think you can get some nice abstract artificial looking stuff out of it. Okay, so
I have a question. Can you use them
Yes,
both at the same time, the spotlight and the directional light?
yes, wow, Tom, that's actually what I just wanted to show.
Okay.
The system is developed so that you can use multiple lights in conjunction. I try to make sure that it works with as many lights as possible. So, wait a bit, I'm not falling again. So, yeah, that's it. So, I'll just press cast shadow. Voila. And we have a second shadow, and we have two shadows that are overlapping, right? So
Nice.
Increase the height a bit, turn the intensity down, that much, yeah, like this. Okay, and as you see, we have overlapping shadows. And as you can also see, now here we have a hole that is leaking. So what we can do now is we can check which light is causing it, right? So I deactivate cast shadow. It's the directional light. Okay, so now I know it's the spotlight. And here again, maybe we will change the default value, but if we decrease the bias, you see our problem is gone. Right, and if I add the bias again, it's there. So yeah, just try playing around.
Looks way better. I think that should be the default, also for normal offset probably. But yeah, cool.
Yeah. Like default values are subject to change. We'll definitely configure that a bit more thoroughly. So yeah.
So if you now rotate the torus, then that would, with the two shadows, would be a nice effect, I guess.
Yeah, let's try that. I'll just use a simple timer for that. Let's increase the speed a little bit, but you can already see it. Let's change the spotlight's position a bit. No.
Yeah, this is really cool.
-1, maybe 3 or something. Ah, yeah, there we go. Now our camera. Fuck. Again. Sorry.
What? Language, please.
Yeah.
What did you just say?
I'm trying my best to be a responsible grown-up, okay? Don't judge. All right, so yeah, now we have 2 maps going.
That's cool.
Let me get rid of the review. Yeah, so 2 shadows. We're still seeing... Yeah, okay. So we're still with the default algorithm, right? So let's try changing this to PCF. Right, it looks very, very cool, I think. Poisson. So here we have the problem of the sample distribution. So when you see these artifacts, your sample distribution is probably too low. I forgot to reset it back to 500. And there you see, we can also increase it. So if you add more lights, you also need to like try and change the different parameters of the shadow op as well. So like always work in conjunction. You know, you add a light, like you check, okay, do I have any biasing problems, edge artifacts, whatever. Go back to the shadow op, try changing the algorithm, see which parameters there make sense. Like it's all a trial and error and like step-by-step process, right? So don't expect to like get immediately great looking results out of the box. Like I say 60%, 70% of the time you will, but don't be scared to dive into these parameters. Okay, now let's try the VSM for quick reference. And here you go. We have an artifact, right? So this time it's again our spotlight. Now what's the problem here? You can see at the border, turn the direction light off. So VSM is very angle and position dependent, right? So I could try and decrease this value or increase it. See, nothing happens. So this is something where you got to check your parameters. Oops. Sorry. Increase the near value. See, that solves it a lot of the times. Like with the spotlight, yeah, you need different near and far values than with the direction light. So the direction light is usually 0.1 to 20, 30, whatever big your scene is. But with the spotlight, you always have to make sure that your camera starts a bit away from the spotlight because it's very, very subdued to artifacts if not set up correctly. And what you see here now is a problem there. You see these lines that were just popping up there? Wait, let me stop the timer and rotate it so that you can see them properly. 45, maybe. 20, 70, yeah, there you go.
Them. Yeah.
Yeah. So does everyone see these lines? This is something that will only happen with variance shadow mapping, and it's also been the topic of quite a few papers that I had the pleasure of reading. And what you see here is called light leaking, and this is something that's inherent to the VSM algorithm itself, just by design. There is actually kind of no real fix for it with the standard variance shadow map algorithm. There are algorithms that try to tackle this problem using different calculations. I won't get into them right now, but this problem,
don't they disappear then? Oh.
Yeah, let's try that. I can blur it, but it should not disappear actually.
It gets,
see, they just get blurred with it. So a note on the VSM algorithm, now that we see the light leaking. It's called light leaking. I think I didn't say that yet. And this is something that happens when, see, I also put up my light here. I think you can see it casting. So imagine the shadow is being cast onto my hand, right? If I have 2 objects, my fingers, like one casting a shadow onto the other finger and then casting it on my hand, so the floor, you basically get what you see here. It's basically 2 geometries overlapping each other and causing this problem. This is caused by the way probability theory works. Like stuff at borders gets either very high or very low, and this is why you get these artifacts. There is actually no real solution to that, but what you can do, and this comes with a caveat of the blur not working correctly, is you can try increasing the bias and actually increase it quite a lot. Not as much as you would with the algorithms I showed before, but you see 0.1 gets us a little bit there. So 0.2, yeah, that's actually workable. I think we still have some artifacts. Yeah, so maybe 0.3. It will be different from, yeah, so here it's gone, right? It will be different from scene to scene as well. Sometimes like you would need a bias of 0.8 or even 1 to actually tackle it. The problem you get with increasing the bias is you get less blur. So if you look at the edges here now, they are not as blurry as they were before when I put it on 0.3. You see that? Is that visible for everyone? So you always have, when working with variance shadow mapping, you will definitely experience this light leaking problem. There are two solutions. One is increasing the bias with the caveat that the blur kind of starts looking weird, or the shadows can also deform. Right now we don't see it as thorough. Let me try change the rotation to 0 again. Yeah, okay, I'll just increase the bias here, so you see what I'm talking about, right? So if I increase it to 1, the blur is gone. If I put it on 0.3, I put it on 0. So sometimes you will only get rid of light leaking if you set the bias to 1. If you have that problem, it's probably better to use another algorithm, because like you're
can you now increase the blur, and is it coming back then, or
no? It will just deform the shadow. You see?
Okay.
Yeah. This is a problem with the way the algorithm itself works. Like there's no fix for it in the standard version. I'm still thinking about implementing so-called exponential variance shadow mapping, which tackles this problem but comes with its own light leaking artifact. So the whole probability theory shadow mapping algorithms, they have these light leaking problems. What I would advise when using this one is usually VSM and game engine stuff is used for like terrain shadow mapping. So if you have like a large area with not so many overlapping geometries, but you have like, I don't know, a mountain hill, or like, I don't know, generated, mountains, this kind of stuff. This is what it's usually used for. If you take care on designing your scene so that no two geometries overlap in the shadow camera, you can definitely get by with variance shadow mapping. Can you click again, Pando? So I can move the mouse again. Yes, thanks. So let me set the bias back to 0. As you see here, you have to do it again. Sorry. Yeah, thanks. We have this tiny little bit. Maybe it's also our camera setting. No, let's try. Yeah, you see. So there's definitely ways to work with it. If you really experience this problem of light leaking and you can't get rid of it, just use the Pcf algorithm or try designing your scene so that no two objects overlap in the shadow map camera. This is the advice I can give you with this algorithm. But if you have a scene that fits it, it will look the best. Any questions to that?
None so far.
Check. All right. Then there's one last light I can show you if you want to. It's the point light. So maybe we can add that to the scene really quickly and check what it does. Let me remove this up. Wow. Man, I worked for 1.5 years here and I didn't even know that shortcut. Terrible. Okay, so let's take the point light. So as many of you might know, a point light is an omnidirectional light, so it casts light into all directions. And also when you want point light shadow mapping, you have to render the map in all directions. So what you're doing is you're using the cube map to render it. If you want to go a bit more into technical detail, what rendering a cube map means is basically your scene is rendered 6 times instead of 2, so 7 times with the actual rendering of your scene. So use it sparingly. Sorry. But
I
what
was
you get
thinking
is
maybe we can toggle that you don't render like the top view or stuff like this, because many times you don't need it, for example. But yeah, another thing.
yeah, we will definitely optimize this for sure. We see it gets a border. So point light uses cube maps. It has the camera that you see here. Sorry, I can move this away. So what you see here in the texture preview is basically the cube maps camera folded, right? So each square is basically one direction, all directions. So let me change the position really quick so we see what happens. Like try looking at both the scene and the texture preview, right? So I put that on 10. See, we're getting very far away. Light changes, so let's get close to it. Try raising it up a little bit. Okay, so as you see with the variant shadow mapping now, we get a huge load of this light leaking issue. If you want to use point light shadows, which I would recommend only if your scene is pretty simple because you're rendering it quite a few times. I stress tested this stuff, and it's definitely possible to use like 2 or 3 point lights, but the more complex your scene gets, if you work with 3D models that have a lot of vertices and stuff, it can get very slow very fast. So you better watch out with that. Another thing with the point light is I wouldn't use it with variant shadow mapping, because right now variant shadow mapping depends on blurring your texture, and WebGL1, neither WebGL1 nor WebGL2 allow for seamless blurring of cube maps for the technically interested. So if anyone knows a way on how to blur cube maps in WebGL, please hit me up on Discord. I will gladly implement it. Like, I couldn't find a way. So you don't have the blur parameter with the point light. Sorry, that's not the point light. That's the point light. So you only have near far values and the bias, maybe it's, yeah. So usually when you use a point light with a variance shadow mapping, you can increase the bias to 1 because you're not getting any blur, but you will have jagged edges. So if using variance shadow mapping, try using directional light and spotlight only. Yeah, but the other algorithms, they work. So let me show them really quickly with a point light.
So Hadi just now says, as a suggestion, you can turn off rendering of sides of the cube map based on the camera angle, unless you go extreme fisheye with the field of view, that is.
Okay, so the view basically is a perspective camera, which has like
what
an
he
opening.
means, what he means is like you could maybe calculate like, is every side of the cube visible to the current camera? Because right now, then the top plane wouldn't be in the viewport at all. So maybe you could calculate this, but yeah. I think like toggling them manually would be already fine. But yeah.
Yeah, I think the problem is always like the modularity of cables, right? So you will never know how people in which context are going to use it. And the more you have like these dependent options, if the camera field is like this and that pass and stuff, so on, it can get dirty really quickly. So what I noticed from developing it and using it, actually, it's better to have the parameters in there. But I will definitely write that down and think about that, if we can like somehow automatically check which cube face is visible to the main camera or not.
Also, it would be super cool if we could just render them once, the shadow map, and then just not update it. And then you have like, if you have like a landscape, as you say, then the landscape is not changing in the game. Then it could just be rendered once and then always, the shadow map rendered once and then the shadow is always rendered without re-rendering the whole cube map all the time.
Yeah, I also thought that like giving triggering possibilities to when the shadow map should actually be rendered could also be a good idea.
Yeah.
So people can decide for themselves when they want to render a shadow map. So you can definitely like optimize the hell out of it if you're working on demos or something.
It's just a simple Boolean like update or not update. Yeah.
So any suggestions, please write it in the forums or on Discord. I'm gladly to take everything in that you guys propose. It will just make the system better, so don't be shy. Okay, let me switch default algorithm. There we go. Now here, you see these artifacts that I was talking about. These little jagged, edgy things. So the point light, unfortunately, does not have a normal offset because we have 6 directions, right, in which one would be offsetted. Doesn't work like this, but here we can definitely show a use case for the bias. So the bias is on 0. Let me try changing that to 0.1. Oof, that's way too much, right? You saw, but our little jaggy artifacts, the little jaggy artifacts disappeared. So let's try, like with the bias, really the values 0.00001 to 0.1 are more than enough most of the time. So this is a bit too little. Yeah, there you go. So just so you can see it again. Here we have these artifacts. Like if you care about this stuff, I do. So I'm very meticulous about this thing. So whenever you have these kind of artifacts, just increase the bias a tiny little bit, and you will most likely get rid of them. Okay, let's show the Pcf algorithm. Take some samples. Here, everyone write that down. The sample distribution not only works with Poisson algorithm, but with a point light, it also works with the Pcf algorithm. This is also written down in the documentation, but let me just decrease this. So you see, we can kind of increase or decrease the softness of the shadows. So if I put it on 50, you see we get a lot of artifacts, but
looks cool.
We get some cool shadows. So these artifacts, they are called shadow acne. You usually get them when you don't write your system properly. This is what the bias is usually for. So maybe we can try increasing it a little more here as well and see if we can get rid of them. Yeah, you see, the more I increase the bias, the less of these artifacts I get. But since so as you can see here, we still have these kind of moire lines while using the Pcf algorithm, the point light. So a general hint, a point light and Pcf algorithms, like it's taking a lot of computing power. So be very careful with that, especially if you're on weaker systems like I am. But yeah, let's try increasing the bias here a tiny bit more. So yeah, now they are gone. All right, and the last algorithm, Poisson, it also works with the point light. So here again, try changing the sample distribution, see what happens. So here, maybe lower values are good to make it blurry. It's really hard to get cool blurred point light shadows, so really be careful when using the point light. But as promised, our system works with multiple lights, so let's add all the different lights and see where we get. All right, since we're using the Poisson distribution, the Poisson algorithm, and we have a very low sample distribution, let's increase that to 500. There we go. Now here you can see we have 3 shadows. Now, Okay, let me change the direction so we can actually, yeah, there we go. The intensity of every light. So whenever you're using multiple lights, make sure you set the intensity of the lights accordingly. But as you see, now we have 3 lights, each of them casting a shadow. Let's animate the torus again, just so we can see. Hey, I can hear you.
Nice.
Et voila.
Cool.
So maybe I can do a little FPS check with everything turned off. So we're still on 60 FPS with 3 lights casting shadows. Let's just try the repeat op to see how many repeats we can get until this stuff starts to break down. Position. Also, a little tip when working with this stuff, right? If you're using materials on multiple meshes, like try all this, like use all the repeat ops and stuff, everything after your shaders and shader modifiers. So all of this stuff.
Yeah, maybe we should wrap it up.
Yeah. Oh, what? Just really quickly do this, position Z. There you go. So we're still on 60 FPS. Let me increase that a bit. 10, 30. Oops. Yeah, I mean, on this machine, it runs super smooth. Like,
Yeah, for this you should use the mesh instance, so this is not a good test case.
I know. I just wanted to show that it's actually, it can handle a lot of geometries quite well, even with 3 lights on. Are there any questions left? Is there something that I forgot to show? Something you want to know?
No, I think you pretty well showed that we have like a really, really huge new part of cables where you can play around with lights and shadows and lots of different algorithms and settings for everything. So no questions at the moment. But yeah, thanks for the presentation. That was really cool.
Yeah, no worries. And
thanks,
if you guys
thanks
have
for
any...
your work, obviously.
Yeah, great work. Don't you have like an example that's a bit more complex than this?
Yes. Something that we were not able to touch on today, but I want to show 2 things really quickly. One thing is, I think you can see it here, so I'll just leave it here. If some people of you have used opacity textures to like carve holes into models, you can use these same opacity textures in the shadow op to carve holes into the shadows. So here is a basic example. I have this black and white texture that puts a hole into my cube, and I have the same settings that I have in the Phong material with like discard transparent pixels. We have that here in the shadow op as well, so we can use that to creatively design our shadows to look a bit differently and work with textures and stuff. I'm sure a lot of people will come up with cool ideas for this stuff, so you can also define a threshold for the alpha values, right? So let me just do a quick blur here, just to show the capability. So we'll take the fade out to 0.5, no, 0.3, and now you will see. So we have this faded out texture, and now we can use the threshold to actually decide which parts we want to blur, right? So it's another thing. And as Pandu already mentioned, we are actually able to use it in conjunction with mesh instancing. So I put up an example here. Let me open it in the editor. So I don't know, maybe you can navigate around it because I'm using the WASD camera, and I'll just talk a bit. Yeah, so as you see, it's actually possible to render shadows onto walls and like have a 3D thing going on. If you look into the patch where it says moving toruses in the patch field, I did a little, I don't know, animation of toruses there. Don't worry about the area ops. It's just basically them circling around. You can definitely use the output mesh instancing, and we're also in the process of making everything work with everything, right? So you will soon be able to use shadows with vertex displacement, and if you cannot already by now, I'm not sure, but
you can use most of them.
Yeah, right. But we're still at it. So if you find any bugs with the shadows, if you have problems with them, feel free to write to me on Discord. Feel free to post in the forums. I will publish the examples and the full documentation by the end of this week. Anything else? Not from my side, no. I think that's it. Yeah, you can see, maybe look at the cube camera there. You can definitely see what the camera does.
How big is the map for this? 1024, okay.
Yeah. You can try decreasing it.
But I love this, how this looks. Yeah, cool.
Okay. So
yeah, people on the chat are also saying thank you and good job and very cool and nice and stuff like that.
Stuff like that. Yeah, sounds cool. I hope you guys enjoy it, and hopefully in the future we will see some very, very cool patches. I'm sorry I have not been reading the chat, which I'm very, very sorry for. But my computer is kind of old, so yeah.
I think we will see crazy cool patches with this stuff. Totally.
Yeah, nice. So yeah, definitely we'll post this example. I'll document it a little better, and it should be up by the end of the week. So be a little patient with me.
Yeah, cool. Great. Awesome. Thank you. Thank you very much.
Yeah, you're welcome. I'm in the chat now, by the way.
Wir machen bunt also says, great in-depth explanation of the shadow text. Gonna watch this again. So this will go to YouTube after this Twitch stream, and we usually publish these a few days after the stream. So that's your chance of like revisiting all of this.
Yeah. And I guess like also the documentation will be in that format that you can find like solutions to artifacts there or something. But we talked so much about artifacts now, but I mean they are like the biggest problem with shadows. So cool, great.
Yeah, super cool. Thank you, Simo.
So if no worries, if there are any more questions, I will be hanging out a little in the chat. Right now, I need some me time. I drank too much water. So I'll catch you guys soon then. Yeah?
Cool. Okay. Thank you very much.
Thank you.
Thanks, everyone.
See you.
Enjoy the stream. Bye.
Hey, this one I really like.
Yeah. Totally. It's also this there's so much to learn how to set up shadows in a good way.
But it really adds like the light and then the movement. It really has like a really great atmosphere.
Totally, yeah.
And well, from looking at the patch, it doesn't look too complicated. I guess it's like twiddling around with a lot of these parameters that I just learned, but yeah.
Yeah.
So what else did we do in the last release?
I forgot.
It was basically like, okay, really shadows were a huge part of it.
Look, if you make the shadows blue, it looks a bit more realistic. So, okay. Yeah. Let me quickly log in with my account.
I mean, we have like a really massive changelog of all small, lots of little changes. Are there any bigger areas where you've, like, apart from shadows?
Yeah, I would start showing the splines.
Sure, right.
Which is also like a big thing, at least for me. So drawing lines in 3D or in WebGL or in OpenGL in general is pretty hard because you have to build them from triangles basically. So we need a better spline system in K-Red. So this is like the first version of this. I have already like 1,000 ideas to make them better, but they will all work like this. So I would just show it. So we have a new operator spline mesh, which we can just connect to main loop, and it needs a spline mesh material, and it needs some points as an input. So let's just use some random array 3. And then you see splines are popping up on the screen. So lines that are connecting those random numbers basically. So we can just adjust the number of points.
Mm-hmm.
And we can, so the problem with this is like, if you want lines, like there's like a million different lines that you could want. So maybe you want like 3D splines in 3D space, or you just want to draw like 2D lines on the screen. And so there's a lot of options that you can adjust. So if I add subdivide array op here, then you see the lines get much smoother, and now they look much better than before. Let me add an orbit control. So you see this is in 3D. And scale this up a bit. And so there are a few options. So if you want to draw like really edgy lines, like with hard edges, you should go here and say tessellate edges. And then they look much better than before. So there are a few tricks in there because this is optimized to be super fast. So that was the whole goal, that you can draw a lot of lines at once. And this is why you have to make some adjustments and tweak some settings. It's a bit like the shadows, like there is no solution for everything. You always have to tweak it a bit. And but the cool thing is with this, you finally can adjust the width of the splines. That wasn't possible with the old spline system. Because someone forgot to implement this in WebGL, but yeah, with this you can do this, and then you can create like thick lines basically, and you can also you see when I'm closer with the camera, like there's a perspective now, they are small in the background, right? But if you want, for example, like a data visualization or something, like you don't want 3D actually, but you want 2D. But maybe it's in 3D space, but you still want them to be 2D. You can disable this width perspective. So if you do this, then you see everywhere it's the same width, basically. So if I zoom in, like it's super near the camera, it's still the same width as the far ones. And if I zoom out, it looks super strange, but the width is still the same, but in pixels, you know, the width is always the same in pixels, basically. I mean, it depends on your resolution, but they don't get thinner if they are further away. And this is like, often you want this with splines because they are more like a user interface thing or like an overlay thing or something, then you don't want this perspective thing in there. And with this, you can do both, and it's super handy. Exactly. So, and right now, you can also use it to draw multiple splines. So if you use this op array of arrays, I can connect, let's make it a bit smaller, like this. Oops, Windows. So you see now we are drawing 2 lines.
Okay, cool.
So this is super handy if you just have a few lines. There will be a mode, and this is what I mean, we will make this better. There will be a mode that the array format of those points is interpreted differently. So you have like, right now it's like draw a line from A to B to C to D to E, but it will also be like draw a line from A to B, from C to D, and then you can make like disconnected lines with just one array. But this data structure management is huge pain. So I thought, why not also, it should also be possible to just give it like an array of arrays. So however you want to produce that, like with code or with this op, and probably you can also do this with array set array ops. But this one is like the easiest. If you just have a few lines and you just want to draw them with one draw call, then this is the easiest way.
That's the main difference as compared to the old spline system, right? This is basically one draw call in mesh instancer style.
No, yeah, I mean, it's a totally different technology. The other one is also one draw call. It's also super fast, but you cannot adjust the width. So you can only draw like 1 pixel and exactly 1 pixel white lines, which is like there's this GL lines functionality. And usually on desktop OpenGL, you can set the line width, but somehow like it's not in the specs, and the Windows implementation, the Angle implementation, they treated it differently. On Mac, it actually worked. And then they said, okay, then nobody can use it. And then they removed it again. So you have to care about your splines yourself, basically. And yeah, so probably there will be another one. So what this does is basically like it renders rectangles on the screen in 2D, but we already know that we also want like a really 3D extruded tube 3D mesh, which can also work with Phong material and has real normals. So this is probably like the next thing that we do, that this is really in 3D and can be lighted and can cast shadows and all this kind of stuff. So this is basically like the basic material for splines. And there will be another thing where you can draw 3D, real 3D splines, like extruded tubes, basically, later. Yeah, and you can also, that's also, I think it works in the old one, but it's not as nice. You can also use textures with it. So for example, I can connect this gradient op to it. And then you see, maybe just use one line, then it see it better. It basically goes like through the whole gradient.
Okay, cool.
It just maps the whole image from left to right, yeah.
Yeah.
And now I can do Does it have this? No. So I can use, for example, scroll texture. So I can let this scroll. And it's just like I can show you. I'm just changing this texture basically, and it's a really neat effect.
Yeah, absolutely. It's super cool.
And so if you can, like, this texture can be really small, like 8 pixels or something. Like this costs nothing. It's really handy, and this looks very American.
French, I was about to say, actually.
Yeah, and that's super handy. One thing I discovered that you can also use the texture mask, but I think there's some problems. So if you want to disconnect, like make them like little lines, you can also draw them transparent at those. Let me try that, because I think it's just some setting problem. So I will generate another texture. Which uses the stripes op, like this, and connect this to the mask.
Cool.
Make this white, and then you see I can control like how many. Yeah, and there's the bug, like how many little steps there are. So I can again use this scroll texture on this first. But yeah, so there's a little bug which I'm working on, or will work on. Maybe it's also the interpolation. Yeah, whatever. But this will work in the next update. But yeah, this is quite nice for visualizations and just drawing some line effects on the screen. You can also, I think, I can also control this offset thing here. I forgot that. Yeah, you can also, yeah, this is also cool. You can say like the texture is repeated by the length of the spline, and then you can also do cool stuff. So basically, maybe this is what I was missing. But yeah, so you can probably also create the effect of transparent parts in there. But yeah, really neat effects.
Yeah, it's really cool.
Also, if we add some blend mode, you can see they
Nice. Yeah.
go through each other. Yeah, there's a lot of stuff you can do with it. Also, like for little things that happen in your patch. It's really versatile, I think. Yeah. Any questions about splines in general?
Splines in general. No questions so far.
Yeah. Yeah. So that's
I really like this, and we can like do, I don't know, stars and lasers or whatever with that.
Yeah, we already did a website with this, which uses this technology as wireframes that are super colorful, and I cannot show yet, but looks really cool, and I'm really happy with the rendering style. It's also there's no aliasing and those kind of problems. It works really well, and now we just need this in 3D also, or like real 3D with normals, and then yeah, it's cool. Yeah, also, okay, should I go to the next one?
Sure.
Yeah, just go through, let's just go through them. So they are also from Zemo, by the way. It's really the Zemo release this time. So this is Fresnel shader, but it's not. We had this like in multiple materials. We had the possibility that you can add Fresnel shading to in the material, but this one is now a shader effect, so you can apply it to any material you want. So you can make a basic material basically and use this with and apply Fresnel shading on top of it. So that's really interesting because it just works with everything. So you can just set a plain simple color and then add this on top, which is super handy to have.
What does it do is about the glow shininess of the thing, right?
So basically it looks at the normals. So if they are really like the angle between your camera and direction of this triangle, so to say, is super high, then it's brighter, basically.
Okay.
And so and this is used like for Nintendo games quite a lot. If you want a cartoonish look, it's a really simple trick, and it's also really not that expensive. And yeah, you can even fake some cell shading with it, or like cell outlines if you adjust it more. Yeah, that's super cool. Also, I think I tried this out locally, but yeah, really cool thing. Also, something that was requested for so long, and I don't know why we never did. So finally, Simo did it. we have a nice merge request, merge conflict in here. So basically, you can write math expressions in an op, and they get evaluated at runtime. So we have two math expressions here, and you see like how is this built? So you see here our formula basically to animate this thing. And here you see the output as a graph, and you can just change this to, I don't know, multiply it, and then it's not so far anymore. So you can just write formula in here and gets evaluated every time input value changes. And the cool thing is we also have this for arrays. So you can input a whole array and you can calculate the values in this array. And you also get like the index and you can work with that index. So I don't know. So I can just like change the speed of the rotation here. I don't know. I haven't tried this. Okay, this is wrong probably. Okay. So now it should rotate and then rotate back, but you don't see it because this is super fast. Yeah, so you can input like up to 3 arrays into this and up to 3 numbers, and then work with those values in your formula. So you have ABC and XYZ, and also you have I, which is the index. And yeah, it's super handy because it's not everyone's thing to just combine a million math ops. Often it's also way less space to just input a formula in here than to build it with math ops. So we wanted this for a long time, so finally we have it. Super handy, I think. So that's the math array ops, math expression ops. I think also like Andrew Mark will show it in some tutorials. I'm pretty sure about that for particle systems or something like this. It's super handy also. Super duper. So yeah, so we have another op, which is also like an old op, but we just updated it. So we have like texture. So in our last update, we just featured the MSDF font, which is super happy and I really love it. But sometimes you just like, we had this client and it's like, yeah, okay, we now need Korean, Japanese, and Chinese and traditional Chinese to display. And we're like, okay, so you cannot do this with the MSDF texture because like those textures you generate, like there would be tons of them because like traditional Chinese has thousands of characters. So we updated the texture op, which basically uses your browser's font rendering engine. And in the past, it only created a texture. So you see it here. And this is the texture that comes out of it. You can still use that, but we also made it possible that you can just render it to the screen, which is super handy because often you just want like a predefined fixed area where you just write text in there. So this is possible with this op. So I can make this border visible, which is basically for debugging purposes only. So I see where the texture is. So you see when I type too much, it will shrink down. This is because of this maximize size. If I turn this off, oops, right. You see it's actually creating new lines. So you can now set like how many lines you only want in there, so you can really control about the text rendering. That wasn't in there before, and it's super handy. And this way you can say, okay, I want to create this area which has 3 lines, and it breaks automatically. And if it's over those 3 lines, it adds this ellipsis point thing there. And yeah, that's just super handy. And it's just super handy that you don't need a basic material and the rectangle, and then you have to set the rectangle to the correct aspect ratio of the texture and blah, blah. So if I just change this, you see it still looks correct. It just changes also the area. So the pixel size is also like the size in 3D, the aspect ratio of it. So if you don't, like if you really need, like you can also type emojis in here, like it really renders everything like your browser engine. And that's super handy if you have like Asian fonts or you don't know what people type in there basically, then you can use this and it will always be shown basically if the browser can handle it from the user. So yeah, this is why we have different text solutions in cables. Because everything needs to be treated differently, basically. That's this. Also, another thing is like if you have those texture problems here, you can now. So this thing has its own material built inside. You can say hard edges, and then you see it looks a bit like it's the same algorithm basically at the shadow maps. It makes those edges harder. So. It looks better when you zoom in and you have really big textures, so sometimes this helps. And this is not MSDF, this is just like a hard threshold where it renders full opaque and and full transparent. It's quite handy for this kind of stuff. Yeah, and it also has some more options like the anisotropy and this kind of stuff, which doesn't work with hard shadows, with hard edges, but yeah. So you see this is super blurry there. If you change this value, then it gets much better. But yeah, with this perspective, there's not much hope to fix it. But yeah, so this is also super handy to get some text on the screen really, really quickly.
We should maybe do a stream on just doing text in cables, because there's so many different like ways to do it, and all of them serve a purpose. Like you can do it in CSS, you can do it in text texture, you can do it in MSDF, you can load a font file, do TTF. Then
there are like I think there are 3 or 4 GL methods how to render text, and everything is like has a different purpose, right? So this renders everything, you throw it like the text mesh is super fast, and to change this text is basically uploading a new texture from the CPU. So this is not fast when you update your text a lot. So then this is not good. So the MSDF and the texture text are way faster than this to update and change. So yeah, everything has its pros and cons. But yeah, you basically have to learn like which one is the correct one for each use case. There is no solution for everything, like as always, basically. But yeah, like we think it's a good idea to have like those multiple systems in there, because then you have the choice. And, I mean, it's a bit harder to learn, but yeah, you have the choice, and then you can decide like I want to draw 100,000 characters that rotate, right? So that's a completely different technology than just showing some characters in 2D on the screen or something. So, yeah. Exactly. So you want to talk about the format button?
Yes,
I wrote that down in my notes. Like, why is that funny?
Yeah, I want to talk about the format button.
Yeah, so I always get mocked in the company because my formatting skills are so awesome. So Stefan built something.
You want me to take over?
Oh, you can, yeah, sure. Yeah.
Does this work then? It seems to be. Well, it's actually a bit more not only about the format button, but we kind of worked on in the background on making collaboration cables a bit more a bit better actually, and less bug ridden. And we actually figured out that lots of people are doing are writing their own ops. What? Sorry.
They are all crap.
Yeah, it's okay. And we have this editor, and we had this before, right? And you can save these, and now you have the. This is correct, and this is not even right. So now this will, according to our internal style guide, format your code, which can be really helpful to clean up stuff. And maybe we find something else in Tom's user ops that we can use to just format. Okay, this is okay. Nice. So this is one of the things we did. Also, we tried our best to make these buttons only appear when they are actually relevant to you. So this is not really showable right now because Tom is like the only person, Pano is the only person who may edit everywhere and everything. But in general, you should like not be presented by a save button and then save and be shown an error message. This goes for basically all the core base ops that you always can see the source code of. This could be formatted. Well, this looked okay.
I think it's not working with base ops. Then you have to reload.
Okay. And also a few things that we did to make collaboration a bit easier. There used to be like a really nasty bug that made user ops basically being non-shareable. So whenever you went into a patch and a user op was in there, be it a public patch or one that you have been sent through via a secret URL or whatever, you saw the editor, but you weren't a collaborator on this patch, that would then bail on user ops, and this is no longer the case. You can actually see and use user ops in public patches. You may not edit them if they are not your own. But you can in patches that you collaborate with. Maybe I show this quickly. I don't know if people really know this or use this a lot. But in patch settings, you're usually you're able to add collaborators to your patch. You can send them an invitation. They get an email. They're being invited to this patch, and all these collaborators work on this one patch and their own user ops as if they were their own. So you can, if you collaborate on a patch, use the user ops of other users, and then also publish this patch and have the user op usable there. Also, one small thing that we never noticed, if you have collaborators, one of them is the owner. That button works now too. I think that was reported by Kevy last week or something like this. And last thing, to make it more easier to work with patches, we always sometimes do save as, and to make a new version or send another version of the patch to the client or whatever, then we do save as and work from there. These will now keep your collaborators in the patch, and then you can continue working with them on the new version, basically, of the patch.
Yeah,
all of what I
this
said,
kind
like,
of stuff. Yeah, sorry.
all of what I said also goes for libraries, basically. This also didn't used to work, but if you have a user op that, for example, uses a library that is the Lottie player or whatever other library, Perlin, PostNet library, QR code reading libraries, whatever we have in there, Tone.js, then these will also be available to all the other people that somehow managed to end up in this editor of the patch, not only collaborators. I hope this well, this is actually one of a way that we want to go more, because more and more people seem to be collaborating on patches, and we're thinking about doing a lot of more stuff to make this more convenient. One of the biggest and always requested features, and like basically a dream of ours, would be like actually being able to live edit with the same people in the same patch. But while we're going there, we're also thinking about team functionality, sharing and copying sub patches, maybe doing like a library of smaller patches that can then be templates for the team to start from there and use from there. So apart from all the super cool 3D stuff, we're also always sitting there and thinking, okay, like how can we make this better to work in a team?
Can you hear me?
I don't see you anymore though.
Okay, but that's good. Yeah. Yeah, this kind of stuff is really hard to get right, I think, and it's because everyone uses it differently. And yeah, we need also feedback. So a lot of this was reported by people because we use totally differently than other people. So if you have any problems with this workflow, or like how can I collaborate better or something, or like you wish you could, then just tell us what is missing there, because yeah, we want to know like what kind of struggles you have when you're working together, and we really want to work on this and have more features for people working together, basically.
Yeah, and as always with these like kind of workflow related stuff, there's like not one single way to do it, but it would be really nice to hear more about how people with the current state of cables work together, and then basically go from there and try to find features that make sense.
Yeah.
So while we're at working together, I don't know if you wanted to show this, but we want you to work with us on stuff that we did. We made, yeah, this I leave, right?
Yeah.
So we moved our documentation to this new URL, and moved a lot of the stuff over, added an FAQ that will then be filled by us over time, and a lot of stuff is in there. I think CMOS shadow documentation will also eventually end up here. And we're now basically made it a lot easier for us to work on this documentation. Well, apart from like the actual documentation in the ops and then source code documentation, this one like a high level FAQ style documentation. We made it a lot easier, and because we did, you can now help us. This is like a public GitHub repository with the cables documentation. And for every page, you can basically go in here, scroll down, and whenever you see something that is no longer right, could be done better, could be explained better, or if you have an FAQ, you can always go in here if you have a GitHub account, and then edit it and do a pull request, and then we could use your help on improving this, because as you can imagine, it's a lot of work to keeping the actual the documentation of the ever-changing ops and more features in sync with these stuff that cannot be generated. And so whenever you see something that is not up to date, or think something could be better, well, write us on Discord, or would be even better just edit it, like editing. I'm not doing this now, but okay. Yeah, you can basically just do a pull request here, and then edit whatever you want, or add FAQs, or I don't know, fix typos. So these are the bigger things when working together in the release. What else do I have on my list? The format button I talked about.
Yeah, the only thing that I can think of is the upgrade button.
Ah, yeah, right. We have this. If anyone's what? Why is it doing what? Am I not in here? I don't get it. Okay.
You're pressing O and not P.
Right. We get this patch statistics. Do you remember what's the record on that one? Aren't like Android?
I think 4,500 ops. Yeah.
Yeah. So that's a benchmark to go for, or maybe not. I don't know. Worked really well for us though in that project. And the upgrade button. Do you want to do this? Because then.
Yeah. So.
Basically anything with the
sheet.
This okay.
This is how I test this.
Maybe not use this example patch, right?
Yeah. I'm not. But yeah, whatever. So if you have if you open up your old patches, and you see it says there's a newer version of this op available. I mean, you don't need to update, but if you really want to work on this patch, then if you continue working on it, then you should upgrade or update all your ops, basically. So what this does is basically we have something like this. We see a newer version of this op is available, basically. So let me just make it red. So it's really red. And we see this is an old version, and I can now click upgrade. And you see we fixed this awesome warning text. So this will replace the basic material v2 with basic material v3. So all old ports are available in the new op. It should be safe to replace with new version, blah, blah, blah. You should really be careful with this, like make a backup of your whole patch before you do this. But now I can click really upgrade. And then you see it was replaced with a v3 op, and the color is still red. So it tries to match like all the old ports to the new ports. And then you can hopefully use it in the same way than the old op. So
you can also do this in place, basically. So if this would have been connected to any kind of texture or trigger or whatever, then that would be in place.
Yeah. Hopefully. Yeah. So you see, then it's still connected. So we found some really edge cases that we will work on, but all in all, this is super handy, and we need this to update all the examples, which is really important because they are so old. And I think it's tomorrow I will sit down and update thousands of patches, basically, or hundreds of patches with this system. So this is super handy.
Also really useful if you go back to a patch that basically back then used Phong material or directional light or any light that now has the ability to work with shadows. Then you can just click on update. Your Phong material will get a lot longer, and you have all the new options in there, and can then continue working.
Yeah, I mean you will get those problems that if you replace the light and don't to the newest version and don't have the newest Phong material version, then there could be some problems. But yeah, so at least it's possible in a way now, and we're still figuring this out, but it's a good step.
Yeah, I did
right direction.
I don't know, I did 50 example patches or something like this, and updated 300 ops in 1.5 hours on Friday. Then I was really, really done with it. But I guess that would have been a lot more work before.
Totally. Yeah.
So what else on my list? Main loop can do something magic now.
Yeah, so we have this new option when the patch is not focused. Then it will reduce the FPS, so your clients don't complain about their fans so much anymore because they just have the patch running in the background, and the fans keep on spinning. So you actually can see this if you have the performance up. You see we are rendering at 60 FPS right now, and so this is on by default now. So we are rendering at 60 FPS, and when I now, open another app, so this is not in focus anymore, then it will be reduced to 30 FPS, which most of the time is enough to let the fans stop. You can also always, we have this op window has focus or canvas focus, so you can do your own detection. Maybe you just want to, so if you do this active and connect it to has focus, so now you see when I go to the calculator, then it stops completely. So this is even more safe, but then you don't have any animation in here. So you could also set your own, you can set it to 10 FPS with a bit of logic, so then you can control how much the computer has to work when you're not in focus. But this is a good thing to do if someone complains, or if you're not if you can expect that this patches, if you have a website or an application with multiple windows and this will be keep opened in the background often, then you should definitely do something about this, because it's just good to not burn so much power.
It's also just being nice. I mean, if you integrate a patch into a website and then people have like 50 tabs open and one of them is like rendering in the background, a lot of stuff.
In the top it's already pausing, but for example, if you have music playing, then please control this music with when you switch a tab that you pause the music, because it's super annoying. Except you want to do like a SoundCloud website or something, but most of the time it's super annoying to find this website. Yeah.
Any questions anywhere? Tito says a lot of stuff that makes the patches smaller. Yeah, that's always a bit of a goal, to have like stuff being compressed and not being super complicated. I think it was about at the time when we showed the math op. It's also like a really gray area, because we also don't like super massive ops that do a lot of stuff. So it's always an in-between, and arguing about like, okay, does this have to be one op, or should these 5 ops be one op?
Yeah. Can you force some calculation to happen in the background so the frame rate doesn't drop? I don't know, not really. Yeah, what kind of calculations do you mean? Like, do you have an example patch or something? Or like, I mean, one way is to basically cache your calculations. So you do them only once, and then, for example, use a trigger once. If it's a triggered operation, to only calculate it once, basically. So basically the magic is like, just really control what you are doing is really needed. So for example, that we could also show, it's also from the release, I totally forgot it. So one way to do this is like the trigger once, or the trigger limiter, so you only calculate it like every second frame or every third frame while you render in full frame rate. But we have, for example, now this thing, which we used in a big project where we have to render like a huge, like a long scroller. We had a long scroller, and we didn't want to control this manually, what is visible on the screen. So imagine you have like 1,000 objects, and you don't want to render them all. You just want to render what's on the screen. So you can draw this bounding box. You can create a bounding box. I will not go into detail, but you see this yellow box here. This is basically the bounding box of this sphere, and I can detect if this is on the screen. So I can just cancel a whole lot of rendering and maybe also calculations when this is not on the screen. So you like before you optimize an algorithm or anything, just like the first thing, like the easiest thing and the first thing that you should do is like, do I need this right now? Like, do I do this too often? Or do I need this at all right now? So maybe it can be just calculated in an array, or just only needs to be done when this is on the screen or something like this. So those things are like the first things you could check. So there is no magic background, sadly. I mean, we have like those multi-core computers, but it's not really that easy to move tasks to the background. I mean, there are technologies for this, even in the web browser, but it's really hard to do, and most of the time you can get around this. And this would also make cables way more complicated, because you would have like multiple patches running on multiple processes or threads. So right now there's no magic background thing. Yeah, so he answered already, right?
Yeah, I think there's a lot of different types of calculations, and what we often do is like basically pre-calculating all the data preparation for if we get static data, then just make sure that you're not preparing this static data that never changes by 60 frames per second. Then there's other stuff you could fill array buffers, I guess. That kind of goes into the same direction.
Yeah. So one thing I also want to show is we have those ops. They are also quite new. Those filter ops. Gate. Those gate ops. So I don't know. Imagine like we have this as a timer. I need to switch this off. Then. So we have this gate number thing, right? So you see this is not outputting the value. So imagine like we have this, I don't know, it's not really heavy, but we have those calculations down here. And as you can see, they are not changing. They are not calculated anymore. So if I just open this, then you see we have a value in here. So this is the old value that was calculated when I just opened this. So so for example, if I just wanna, I just want to calculate this when I'm, when the mouse is on the screen, I can connect this to mouse over. So you see it's not active. So when I move my mouse over, then it's calculating. So this is also one way to control when something is executed. And you can do this with arrays, with objects, with a lot of stuff. It's basically the same with the if true, then op. So this is not executing because the Boolean is off. So when I activate it, then it's triggered. And this is the same with data, with values, basically, which is also super handy to control stuff. Yeah. Yeah, async stuff we don't really have in cables because most of this stuff is working in the GL loop. There are like file requests and stuff like this, which is asynchronous, but yeah, most of the time we don't really have it. Yeah, I hope this answers your question. If not, then maybe build example patch and post it on the forum with the problem. And yeah, this hold value op, yeah, it's also something maybe we should look into and make this easier for people that switch from other visual languages. Yeah. Cool. So actually a question that was nice.
Yeah.
I think it's yeah, please. Are you keep it visual, by the way?
I think so.
Hi, keep it visual. Is there a way to get the camera fly around the scene randomly with the custom speed? Yeah. I think I would look into. I would just build splines and let the camera follow those splines, because then you can really set up, like you can model your spline basically. We can try to do it right now. So let me see, like, okay, I need to find the op that I mean, but yeah, I will try it. So Windows, yeah. So let's build a little scene. Let's put a cube in the middle. So, and now I want something to fly around this basically. So I want to basically model an array. So how do we do this? Like maybe we just start with a random array 3. And let us visualize this. Let's just use the simple spline because this is just, we don't need a material or something. So this is our spline right now. And we want to subdivide this. And actually, I don't want random numbers array 3 because we have this handy orb sphere, point sphere random. Which it's not really visible. Let me show this with the point material and the point cloud from array. So you see we have those points on a sphere basically. So we can say we have way more, and then you see it perfectly fine. And if we connect this by splines, it looks like this actually. And so I just want way less. And I want to subdivide this. So now you see it's not on the outside of the sphere anymore. I mean, the points are still on the outside of the sphere, but they go into through the inside. So we have this really cool orb, which is like sort array 3 by distance. So so this always searches for like the next point, like the nearest point from the current point. So and this sorts it by this. So you don't have so many lines going through the middle. So let's just make this bigger, and then you see it a bit better. So there are not many lines going through the center. So probably you can use some array math to remove like the inside. Actually, we want this like this. Yeah, that looks much better. So now, so I was subdividing it before, and this is not really helping this algorithm. So if I subdivide it after, then you see like the points are really on the outside of the sphere. So that's cool. Now we could use a camera. I would use the look at camera because I'm just like the simplicity. So you set like you have an eye coordinate, and you have a center coordinate. So we can just start, well, let's just not use a camera right now, just use a sphere just to visualize it. Make this really small and transform the sphere. So this is basically like our eye or our point of the camera later. So we have this, those orbs to interpolate arrays. So for example, interpolate arrays interpolate numbers array 3. So this one, you just give a number. So this is the index. So we have 55 points. So 55 is the last point, and it will just output the coordinate of this last point. So we can just connect this to the transform like this. And now I can just scroll through this, and then you see we are smoothly interpolating between those values in the array. And I actually lied, I guess. Probably it's 150 is the last point. Or is it higher? We will try this out. So, so we can just put a timer here, basically. And then it just follows this spline. And there's one, oh no. Okay. Ah, yeah, we don't see it because it's under the floor. Yeah, so for this, I would say we just use a... let's just ignore this for now. This can be solved with array math, like Andrew showed this a million times. I'm just lazy and remove the rectangle, and then we have it going through around the cube. So now I will use the look at camera for this. So I can say, look at this point that is moving right now. Oh yeah, and the orbit controls has to go. No. So now you see the sphere is always in the center because we are focusing on the sphere right now. So now we want the look at camera, like the center. Let's just look what happens if I use the same value for the center. Now this is already, this is probably stupid because it's the same value, but if you only have one, then you see already like there's a moving camera around the scene, but it's not good. So what we want is like, we want another one of those. And we just make, use the same timer, but just, sorry. Just offset this, so just subtract, I don't know, 22, and connect this to the center. And then you see we're still following this sphere, but if we turn it off, then you see we're just following the path. So if you want to look into the center, basically, you can just change this array, for example. And make this a little bit smaller. And then you see the camera is more or less focusing on the center of the scene. So, I mean, it's not perfect, but with tricks like this, you can already build like a nice camera setup. So if I make this bigger, yeah, then it behaves differently. Probably you want to do this bigger. It was better before, I think. Stefan, you still there?
Yeah, I'm still here. I'm amazed and like Yeah.
Yeah, what is really cool is like you can, like I call it like modeling with arrays. You can just do so many things with this splines and array setup, array stuff. So yeah, you could just also like cut off the points and make more points on the top, or like make different forms, not only spheres, that work with it, and then you can do quite a lot of stuff. Yeah, so if I would do this, then I would go this way and try to do this basically. Yeah, a half sphere. We think. I think my my headset is out of juice very soon. Stefan, can you say something?
Test.
Ah, yeah. Do we have this? Like, Andrew would know this. So what you could do is like you sort the array, sort array 3. No.
What are you trying to do? Don't you want to
Sort it by the y-axis and then cut them off, like everything that's down there. This works.
Don't we have like an array clamp or something like this?
I'm not sure. Maybe. We have this for the geometries. Yeah. Strange. Okay, that we need for sure. Okay, array clamp. Yeah, we have also. So now, yeah, but okay. So this is only, now we only have like positive values in here, but actually we wanna only clamp this on the y-axis to have a half dome. So you need like an array unpack and then clamp it, and then let's do this. Array unpack 3. So with this you get 3 arrays basically, and we just wanna clamp this one. Oh wait. Then we want the array pack 3. So now you see it's a half dome basically. But I think the clamp, yeah, actually we want something like a clamp that also crops it. So that's not working. Yeah, we need some more array ops, I guess. We need to show this Andrew, then you like when he's back from vacation, like he will fix this in one day probably, or he knows already a solution. But yeah, so it's quite strange that we don't have this sort thing, because that would solve it. Because we have this array crop, and you could say like sort this and then crop by half of it, because it's probably like roughly half of the points are below. And I think you could get some nice result with it, but yeah. I was so sure, but yeah, I guess it's only for geometries. Yeah. Looks nicer, yeah, probably because you're not like have this gimbal lock that you're turning upside down and like on a roller coaster. You're right. Hey, have you seen like how good the Control Z work right now?
Yeah.
Right. Yeah. So this is the way I would go and try this out. Also, we have this array follow path, which is also a bit like this. And you could also, like, if you want this always changing, you could do another one with the other random seed and then interpolate between those two arrays and then change the other one that you're not seeing. And then you could have like something that's always changing all the time. But I don't want to do this right now. So I will just publish this. Okay. Yeah, I hope this helps. Yeah, if you have other, like, tell me if you have other questions, like, keep it visual is one of the, like, the Cabits users that also helps other people. We see that, and we really thank you for that. That's super awesome that you do that. Thank you for this. Yeah. Any other questions? Physics body raycasting. Yeah, we showed this last week, and you can see it in the chat and in the stream. Also, I fixed the physics simulation, which I also will publish soon. Yeah, so I don't want to do this right now completely again, but we will do tutorials about this for sure, and we now have those examples here. So there was a stream last Tuesday, and we set up this something like this also with the GUTF and also like this, and yeah, you can see it, like we published it today only, so you can have a look at the at the YouTube video. So, and the awesome thing now is that you can, Dino asked for this, so I can do this, and you see they are simulated now.
Nice.
And it looks stupid because...
Looks good, doesn't it?
Yeah, but so the mesh instance array is the original array. So this is, when I click now, it will reset. So this is the position where the initial position is, right? So now the physics bodies array outputs a position array. So, and when I click this, then you have like a real physics simulation.
Ah, okay.
It's just, right now it's missing the rotation parameter. So they are actually rolling here, but I will also do this probably the next days. And yeah, which is super cool. And this will get the rotation, and then you can just like spawn. This is because they are all in the cube in the beginning, so you can build nice explosions. And yeah, let's turn off this thing. And yeah, so actually they are already rotating, but we just don't have this rotation output. But yeah, we will continue working on this, and this is super, super cool. You can also...
That's cool.
Bam. Yeah. Yeah, and you still can pick them, so you still have this correct raycasting, picking stuff in here working. So, and it's actually quite fast. Yeah, so there's that. Yeah, look up the stream. There's like the whole setup is explained there. Yeah.
Yeah, I also just posted the video on the chat for convenience. So
Yeah, cool. Thanks, guys. Yeah.
working on shadows, Simo. Working on shadows.
No, I think it's the COVID times.
Also, yeah.
I think we should do. Yeah, I mean, we need those streams more often, also for us, for ourselves, because I also didn't know a lot of stuff about the shadows. This blur parameter I never found. I think we need to put it somewhere else. But yeah, it's we also need to do this internally. But let's not talk internal stuff. Yeah, I think my brain is slowly not working anymore.
you just banged out like a camera simulation after 2 hours of stream. So yeah.
Yeah, that was my last energy reserves, I think. No, but yeah, thank you all, and keep it visual. Like, great questions. Like, maybe next time we can work it out with the Discord chat, and then we can talk to each other. Yeah, great. Okay, guys, and thanks, Titus, that you're back. I didn't see you for a long time. Cool. Okay, guys, then bye-bye.
Bye.